Hi there, welcome to Peppy's Civil Class. Today's question is under fluid fluid mechanics. And the question reads: the space between two square flat parallel plates is filled with oil. Each side of the plate is 720 mm. The thickness of the oil film is 15 mm. The upper plate, which moves at 3 meter per second, requires a force of 120 Newton to maintain the speed. Determine I, the dynamic viscosity of the oil, II, the kinematic viscosity of the oil, if the specific gravity of the oil is 0.95. Okay, so solution. Okay, let's take the data given out of the question. Okay, so we have um each side of the plate, which is giving us 720 mm, okay, which is equal to 0.72 meters. We were told it's a square plate. Okay, LB, right? So meaning we have the 720 all around. So the second data that was given was the thickness of the oil film, which is 15 mm. So thickness of the oil film, which is dy, is equal to 15 mm, which is also equal to 0.015 meters. Okay, what else was given? The velocity which moves. That one is velocity of the upper plate, which is equal to 3 meter per second. Okay, then now there would be a change of velocity because it moves. Okay, so the change of velocity between the plate du is equal to 3 minus the initial velocity, which is 0, and it's going to give us 3 meter per second. Okay, what else? The force required to maintain the speed. So the force required on the upper part, okay, which is F, was also given as 120 Newton. So now we calculate for the shear stress, which is given as tau. Okay, symbol looks like this. Tau is equal to force over area, and the force, we have 120 Newton divided by the area, which is 0.72. So length times breadth, we have 0.72 times 0.72. Okay, and what will this give us? We quickly punch it on our calculator. 120 divided by 0.72. And this will give us 231.48. Okay, or 0.5. So 231.5 Newton per meter squared. Okay. So now we can calculate for we have the shear stress, so we can calculate for the dynamic viscosity. Okay. So I, dynamic viscosity. Okay. Dynamic viscosity, which is giving us mu. Mu symbol also looks like this. Looks like a U, but it has yeah, looks like this. So, but tau is equal to the mu symbol multiplied by du dx. So you have to make mu the subject. Okay. By making mu the subject, we're going to have the tau, which was given as 231.5 by dy 0.015, 0.015, all dividing du. What is du? 3. Okay, so 3. Quickly we punch this one. 231.5 by 0.015 by 3. Okay, this is giving us 1.157. So 1.16 Newton seconds per meter squared. Okay, now we have to calculate for II, which was the kinematic viscosity. Also giving us, looks like a V, but something like this. Now we have to calculate for the weight density of oil. Okay, so the weight density of oil, which is given as a W, like a small w, okay, is equal to 0.95 by 9.81, okay, kilonewton per meter squared. Now when we multiply this 0.95 by 9.81, we have 9.32 kilonewton per meter squared. Okay, and because of the kilo, we can have 10 times 10 exponent, 10 times 10 exponent 3, right? So 9320 Newton per meter cube. Okay, now we calculate for the mass density, which is giving us the symbol. Okay, it's equal to the weight over the gravity. It's a small w, sorry. The weight density of oil over the gravity. The weight density of oil is 9320, gravity 9.81. Okay, now this will give us 950. Okay, so we can now calculate for our kinematic viscosity, which looks like a V. Yeah, something like this. It's equal to the mu symbol dividing the density symbol. So mu was given as 1.16 dividing the density, we had 950. Now this is equal to 0.00122. Let's cross check. 1.16 dividing 950. Yes, 0.22 times 10 is power negative 3. Okay, so 0.0122 meter square per second. Okay, or 1.22 times 10 is power negative 3 meter square per second. Okay.